I'd like to welcome you on behalf of Canon Automation to our today's webinar, CanXL Status and Future. Today we have two presenters. It's Holger Zeltwanger and it's myself, Reinhard Zitzmann. So therefore, I like to welcome Holger. He will be the second speaker. Maybe he likes briefly to introduce himself.
I can do so. I'm an electronic engineer and technical journalist since more than 40 years, and I initiated the CiA user organization and a member of the board of directors since 1992. In addition, I'm active in several standardization bodies, including ISO, for all in-vehicle networks and for networks for commercial vehicles. These both working groups I'm sharing.
Thank you, Holger. So Holger will give us the second part of today's presentation. I will do the first one, the more or less the introduction to Canon Automation, what we are doing with CanXL, what we are currently doing with CanXL, and also some general insight into CanXL so that those that are rather new to CanXL know a little bit what we are talking about. I'm Reinhard Zitzmann. I hold also a degree in electrical engineering. I've joined Canon Automation in 2004, and in the meantime, I'm the general manager of Canon Automation GmbH, which is the commercial arm of the association. The association itself that has no facilities, no employees, everything is treated via the company, and I'm running that company and I'm working therefore very closely together with Holger. So yeah, let's start with the content. As far as I've said already, I'd like to welcome you and I'd like to introduce you a little bit to Canon Automation so that you know what we are doing, who is Canon Automation, what is our mission, and why do we organize events like today. So Canon Automation is the international users and manufacturers group that develops and supports CANopen and other CAN-based higher layer protocols. The non-profit group was founded in 1992 to provide CAN-based technical product and marketing information. The association fosters the image of the CAN technology and also provides a path to future networking technologies. So in particular, the last part is now relevant for us. So we accompany the development, the further development of CAN. So we have to keep CAN meeting the requirements to embedded networking of today and tomorrow. And in this regard, there was the update of CAN Classic necessary with our first step to CAN FD and our second step to CanXL. And we try to give some insights to CAN, to teach people, to educate people in CAN-based technology and to assist them in using the CAN. And furthermore, we also like to not only connect devices, but also humans. And therefore, you see here, we've organized just recently a roadshow in China, several events, bringing the CAN community in China together, updating them with regard to CanXL, so that the users of CanXL and maybe future users of CanXL know how does it work and to whom I can place my questions when I meet some challenges in my daily work. And in the same direction, we organize from time to time, annually, let's say, the CiA member days. So the next one will be in March 2026. It's in Munich, in Germany, or a suburb of Munich, Freising, intended for connecting the CiA community, the CAN community. So it's rather easy to get there because Munich Airport not far away. And it's also with our subject today important. We have there some topics that are somehow CanXL related. The one is rather apparent, where you see CanXL simulation. It's given by Patrick Isensee from C&S Group. But there are also some more hidden ones, like the Ethernet of CAN, or that also some talk about security, the CANSEC ecosystem. So also there, some CanXL related content is behind. So in general, these member days are intended for our members that they can get connected among each others, that they get a technology update, so they can benefit from being an active member in the CAN community, discuss latest trends, and trigger further activities in the CAN community. So the CiA community is a rather large one. We have at the moment about 764 member companies. And of course, these are just the companies. You have to multiply them with a lot of engineers that are sent by their companies to Canon automation events, and they built therefore a rather large community, helping each other, exchanging knowledge, and assisting them in getting their CAN projects work. How can Canon automation assist you, though CiA services? So the center point of our activities is the maintenance and development of CiA specifications. So we did so also with regard to CanXL. So we paved the ground that companies can meet under consideration of antitrust laws here at Canon Automation, either physically on-site or in the web in a virtual meeting room. So it's very easy also to join these kind of meetings from all over the globe, just considering a little bit time constraints, but in general, it's rather easy getting connected, getting informed what's going on in this group, what is discussed, how to understand this and that functionality, and to contribute if you have requirements that haven't been considered yet. So these are the CiA specifications. We discussed them and develop them. The outcome will be then a CiA specification of this meeting. And at the end of the day, if there's a request from the members or from the market, we submit them to international standardization bodies. In CanXL case, this is of course ISO, and there we submit all the outcome so that it can get a standard, an international standard, and an internationally standardized and accepted technology. Additionally, we have to do some marketing for that, so that the public is aware of that there's something new. We go to selected trade fairs, illustrate there that there's something new available. We organize events, or on the other hand, we are available for giving you technical trainings, educations, or we organize testing sessions with regard to CanXL. This will be focusing on plugfests, interoperability tests. Is a certain component implemented in the right way so that is it interoperable to components, to solutions from other developers. So in general, Canon Automation is providing services for system designers, component device designers in a marketing-oriented or technical-oriented way. And I'd like to invite you become a member of this community and benefit from our services. Canon Automation has now a long history. We started in 1992 just to promote CAN, to convince others that the CAN shouldn't be limited to the automotive use case, but can be used in all other application fields all over the world. And when we thought we done our job quite well, there came some new technology enhancements. The first one was the CAN-FD, which was presented by Bosch representatives in 2012 at the International CAN Conference organized by Canon Automation. And while we were still organizing working groups, evaluating with experts how to use CAN-FD in the best way in certain application fields, there came already some requests for a third generation of CAN, and we organized there also a working group, and Bosch, together with a lot of experts from other companies, developed under patronage of Canon Automation the CAN with extended data length field, or that what we know today as CAN-XL. And the CAN-XL, as in former times CAN-FD, was added to the ISO 11898-1 and 2. So let's say the CAN standard is now enhanced and is now covering CAN Classic, CAN-FD, and CAN-XL, all three generations of CAN. With these working groups, we in Canon Automation, we have there a technical committee, which is chaired by the technical director, Magnus Hell from Infineon. With this technical committee, a kind of steering group that says, okay, where do we want to standardize, to specify something, to harmonize something, and not all of our CAN in Automation members are interested in all subjects. Therefore, we sorted it a little bit according to certain interest fields and interest groups. And for our webinar today, of interest is the interest group lower layer. So it takes care about everything that is related to data link layer, physical layer, and so on. And among others, we have there a special interest group, a subgroup, so to say, for CAN-XL. And the chairperson of this CAN-XL group is Dr. Arthur Mutter from Bosch. who is a very active member, very keen on pushing the entire CAN XL story ahead. And he has organized together with a group the workload that is there to be managed in a lot of subgroups, task forces, project teams. And they are taking care about certain aspects of KNXL networking, like what about physical layer aspects, what about the signal shape, what about the quality. There is a physical layer eye diagram group. What about cybersecurity? Can we embed already cybersecurity to KNXL? What about simulation for simulation and testing? What about accompanying the standardization process with regard to testing? And what about higher layer functions that can already embed it in a KNXL controller? So a lot of project teams exist. They are meeting a lot. So I've just double checked. They have had more than 30 meetings just this year, and the year is not over yet. So you see, they are meeting almost every week, one time, at least with one project team, one task force. So very active to make this entire KNXL thing work, to provide you a proper solution that is applicable not only in the automotive use case, but maybe in a lot of application fields outside the automotive too. In addition to that, we have also the marketing groups, and also marketing groups, they are intended to promote that what we have specified, to bring the technology in certain markets. So overcome some language barriers, writing some brochures and so on, identifying conferences where something should be presented. The KNXL group in this regard is a very active one. They have requested a website, have assisted us in filling the content, meaningful content for decision makers so that they know for which kind of purposes is KNXL intended for? Where would it help? How could it assist me? How does it work basically, so that I don't have to be a CAN expert in getting an idea, okay, in this or that regard, KNXL can assist me. There we have this website, and on this website you will also find a link to something that is called KNXL Roadshow China 2025. This was just 2 weeks ago, where we organized together with the marketing group KNXL, then three-stop tour around China, introducing to the Chinese CAN community KNXL, so that they know, okay, what are the pros and cons of KNXL, that they can assess very in detail this technology and can introduce it then in the modern cars in China. So all the presentation slides that they have shown in this roadshow are available on the CAN Automation's website. The easiest way to find it is to go to the KNXL website. You will find the button there at CAN Automation homepage. Click there and you see all the slides. A lot of expert knowledge with regard to CAN, among others, also KNXL is to be found in the International CAN conferences on expert level, where experts meet experts, exchange their challenges, their solutions. The next one will be in Tutzing. I assume a lot of KNXL content will be discussed there, but it had been already in the ICC's 18 version and the 17th one. So just double check, the recordings are available on our YouTube channel. And finally, I like to mention the standardization where Canon Automation is active. And we have the lucky situation that Holger is with us as a convener of the standardization committee, standardizing or taking care about in-vehicle networking, among others, the CAN and the CAN XL. And there they are maintaining and further developing the CAN standards, ISO 11898-1 and 2, and the accompanying conformance test plans. Yeah, so much with regard to the CAN automation activities with regard to CAN XL. I know it was a little bit of a rush, but we have limited time only. Therefore, let's now start with the real topic, the CAN XL. And a short insight for those that have no idea what is CAN XL in general, so that they get an idea. And therefore, we are talking about first generation, second generation, third generation of CAN. What is this? What the meaning about CAN, as it had been developed in or presented to the public in 1986, is now referred to as CAN Classic. And it was intended as a simple network, a bus topology to network electronic control units in the cars of those days to reduce the wiring effort and to simplify networking in the cars, the automotive wiring harnesses. And then there was about 2010 an update necessary because there was some idea, well, we need some more data throughput when it comes to software updates of electronic control units, maybe during system runtime, we need a little bit more data throughput. But now everything is evolving, and maybe also now the times of Corona had been a kind of booster in technology development. And now we see there's a real demand in higher data throughput. I will say some words where this coming from. And this applies also for the embedded networks. And therefore, to keep CAN meeting the requirements of today and tomorrow's embedded networking, there was further update necessary. Volkswagen indicated this to us and to Bosch, and therefore this special interest group CAN-XL developed this CAN-XL as we know it today. And it's not just that we can communicate faster and that we have more data bytes, more payload available. It comes with a lot of additional functions like virtual network support, like support of mapping or carrying Ethernet frames and Ethernet functionality. It allows a very comprehensive description of the up to 2000 byte of data. It allows an addressing, a very detailed addressing of the data. It allows a differentiation between priority handling of the CAN frames and the addressing and filtering of the CAN frames. And all that comes with the same reliability as classic CAN had with the small 8-byte data packages introduced in 1986. The need for CAN-XL was derived from the introduction of the so-called zonal architectures. So the automotive industry wants to map control architectures, as you know, from industrial cloud computing and these kind of things, also to the cars for saving wiring effort. They say, well, why not just collecting all the electronic control units that are occasionally around? Let's save cabling effort and then forward the data and in certain powerful controllers. There we have to sort out the data and to manage, okay, to which application does this data belong? Under which circumstances was this data taken? And what is the quality of the data? And a lot of other metadata together with the pure process value. This means we need large payload, high data throughput for supporting these kind of control architectures. And therefore, there was CAN-XL invented. And as I've already said, it comes now with an 11-bit priority ID. It comes with a data field of up to 2048 byte. It supports a so-called virtual CAN ID. It introduces high robustness and reliability as we are used to have in CAN or in classic CAN. So it has a true Hamming distance of 6. And it gets rid of this dynamic stuff bits. We only have it at the beginning. And then we have a so-called fixed stuff bit. I call it a fixed stuff bit rule, which gives us a higher reliability in the CRC calculation and it simplifies the CRC calculation. We have the more detailed description of the data via the service data unit type. We have the possibility of supporting error frames that can be deactivated. We will hear later on why. This means we have still all the attributes that we have had in CAN-FD and in classic CAN. We have the same start of frame, end of frame. This means we have a certain backward compatibility to CAN-FD and we can reuse a lot of knowledge and maybe also topology that we have had for CAN-FD and classic CAN. Just at a glance that you know what's in common, what are the differences. So the good news, basically, the bit fields are the same from CAN Classic to CAN XL. They differ, of course, in the size and the higher the generation number is, the more functions you may have, in particular in a control field. But the general look and feel is identical. And this is exactly what I said you can reuse a lot of the knowledge that you have already established in your company, in your employees, in your technicians, when you're staying with the CAN technology. And what we see here, CAN Classic and CAN FD had a lot of things in common, but basically they were working like that they have the arbitration field where you have the CAN identifier, which combines the priority of the CAN frame and what is the content of the data field. And in the data field itself, you had the data and maybe some additional addressing function, other proprietary functions. Now, CAN XL is there a little bit different. It just hosts the priority in the CAN identifier. It's therefore called the priority ID and has then enlarged the control field and has there a lot of dedicated bit fields for handling a virtual network channel identifier, an acceptance field, so-called service data unit type. You have an indicator for higher layer function support, the simple and extended content, the so-called SecBit. So as I've said, you have dedicated fields that allows you a simple control of specific functions. In general, we see here now, therefore we spent a lot of bits for the control field. And finally, we have there our data field. Unfortunately, due to the size, I can't do it in the right dimension. But in general, we see here we can control CAN XL in a scalable way from 1 byte data field up to a size of 2048 bytes. So I can adjust a CAN XL frame to the really needed size. We have then there a huge CRC field that guarantees us the high robustness over all the up to 2048 byte of data. I have the acknowledgement and the end of frame. So this is basically the look and feel of the CAN XL, and it provides a system designer with a lot of tools, so to say. The system designer may be enabled to run up to 20 Mbit in the data phase, so-called fast mode is supported. Nevertheless, these communication speeds, they depend a lot, of course, on the intended topology, on the used topology. So this is, of course, for an optimized topology. If you deviate from a line, they introduce a lot of stubs, a lot of star points or whatever, then of course the maximum reachable communication speed goes down. But this might be also an advantage. You have this possibility to scale your network like that and say, okay, I can support the network I like to have, but of course, maybe at a limited speed. Of course, we have this extended data field. There's always sufficient space now for any content in a user-defined size. We have the granularity of 1 byte. This is a big step forward in contrast to CAN FD, where I can only extend the CAN frame in regard to certain steps. A very nice attribute is the vCAN ID. This means I can now differentiate between the real network architecture and a virtual setup. So I can say I group devices that reside on the very same or different networks to a same virtual network. So I can group, for example, all drives, all sensors, all radar sensors to one virtual network, and I don't care on which physical networks they really reside, and I can control them and can therefore run simpler filter algorithms. I can describe this up to 2048 byte of data, so it's a huge bunch of data. And now I can say this or that protocol is supported, J9039, CAN OpenFD, or whatever. Or it's an Ethernet mapping currently ongoing, and this is the related data. This can be very good described via the SDU type. CAN XL comes with higher layer functions if they are supported, is indicated in the sec field. And CAN XL may, for example, support bus load management, may support fragmentation service, so that you can say, okay, at the moment it's not appropriate to run more than 2000 byte. Maybe you just fragment certain segments, 500 byte or something like that, to reduce the latencies in the network. If you want to know it a little bit more in detail, here you see the so-called MAC frame in detail. What I think it's very valuable is that one here that you see, okay, where takes the switching place? We have now dedicated phases in the CAN-XL frame transmission to identify. Now we are switching from arbitration speed to data phase speed. And here, this is a differentiation to KNFD. We do it now in the acknowledge field. How can we switch back with a defined pattern so that we have a secure switching and no certain uncertainties as it might occur in KNFD? As I've said with regard to scalability, you see here what can we achieve by speed. So this is a assessment given by Bosch, and they presented it also at Canon Automation events. That they say, okay, if I run at 60 Mbit in the data phase, what can I really achieve? And we see here they can come up to roughly 40 Mbit average speed because always the wrapper starts with the nominal speed, in our case here 600 kilobit. But I always say don't judge CAN XL or CAN just by the speed. CAN typically is selected because of other reasons, because of its robustness, its simplicity, its scalability. And all these things together allow then use these CAN attributes, but now also at a higher speed at up to 20 Mbit. I have already informed you that the error signaling can be switched off. And the reason is because for allowing data rates up to 20 Mbit, we need a specific physical layer approach, which is supported by something that is called the CAN SIG XL transmission. And here we establish a certain communication between a CAN controller and a CAN transceiver. And the CAN XL controller tells the transceiver, hey, now do something different. Now this is done by PWM communication. And then the transceiver provides another signal different to that dominant recessive shape as we have it for CAN Classic, CAN FD, or even for CAN FD SIG. Now we're driving both edges, recessive to dominant, dominant to recessive. In former days, we would say now logical 0 to 1 or vice versa 1 to 0. Both edges are driven actively in this SIG XL mode. And then we have the possibility to go up to 20 Mbit in this setup. Due to lack of time, I just want to give you some idea that you know, okay, we have a certain degree of scalability. There's a slide shown by Magnus Hell at the 18th International CAN Conference where he said, okay, in general, for CAN Classic, for CAN FD, for CAN XL, the CAN transceivers are doing rather the same with one exception. It's if they're using CAN XL in fast mode. As soon as a CAN controller tells the transceiver, do something else, do now the fast mode pattern, then they know, okay, I have now to switch to another voltage level. We see this here very briefly. Now we are switching over to the fast mode and generating the corresponding voltage levels as demanded in fast mode. Holger, I think he will say also something to the flexibility. We have a high design flexibility here in CAN XL. So the CAN XL controller can be connected to any kind of transceiver and can work with any kind of transceiver, of course, with certain limitations. And it's not always reasonable to do so, but in general, you have a high design flexibility. Every CAN XL controller can any type of CAN protocol, and therefore we have this design flexibility. CAN FD controllers have a protocol exception mode. We can also have mixed operations. I think this is a great news and also a big step forward. Finally, I like to mention our publications. And they contribute very valuable information about CAN XL network design. So in particular, this year, we had some learnings inside from the Plugfest and from evaluations done in the company. So here Magnus Hell introduced what is possible that we can run, for example, up to 20 Mbit in one CAN XL network. They had been tested here in the Plugfest, and what was the outcome of these Plugfests that with the CAN SIG XL transmitter concept in combination with CAN XL protocol. then a big step in terms of bit rates and data rate is possible. Maximum bit rates depends dramatically on the network design and the wire impedance, and the more harmonic the impedance in the network is, as higher the possible bit rate can be. And there are, of course, some aspects that are interfering this objective of having high bit rate, the amount of stub lengths, lines, the number of unterminated stubs, and so on. So very valuable. You see here the source, CAN newsletter, June 2025. Have a look at that, and you will learn a lot. All the what we are currently doing with regard to CAN-XL is given here, all the relevant documents, but I think Holger will say something to that. So I'm switching over then to Holger, where I'm saying, you see, CAN is still a vivid technology and provides you with all you need for system design.
Welcome also from my side. I have prepared some information about the CAN-XL ecosystem. Rainer has also mentioned that what we have done is more than just to provide a data link layer and a physical layer specification so that people can design protocol controllers and transceiver chips. I will also going a little bit into some possible applications and where we see CAN-XL can be used for the benefits in different areas. I will summarize what is the status of the standards and specifications within ISO as well as in CiA. And last but not least, I will give you an overview on existing products or products in the pipeline. So the first thing which I'm talking about is the ecosystem. When we look to that, we have a lot of requests regarding security, and we are working on the CAN-SEC, and we have had a long discussion and how we can improve things which are already existing. And then we decided that we reuse the MACsec approach. And what we are doing, it's very simple. We take the CAN-XL data frame, we map it to a virtual Ethernet frame. Then we provide the security mechanisms from a MACsec. So we have a secured virtual Ethernet frame. We map it again back to the CAN-XL data frame, and this data frame is then secured. So this is a very simple approach and can be implemented in hardware as well as software. But we think that most of the implementers will do it in hardware. And this is a simple way of reusing that what is already proven in thousands of applications. However, there is regarding the key agreement, there is some speed optimization necessary, and Open Alliance will do this in the Technical Committee 17, and we will adapt this later on when this is available, so that we also have an improved key agreement with a speed optimized version of the MACsec key agreement. Security is one thing, but we have also the time synchronization necessary. And the benefit is that this is already existing and we can select different options. The CAN-XL hardware supports 64-bit timestamps for transmitted and received data frames. And now the question is how we can synchronize between the different nodes or nodes in even different CAN-XL segments. So we can use the AUTOSAR CAN-T-Sync. And there are three options which are already existing for CAN-FD and or CAN Classic, for CAN-XL and for CAN-FD, CAN-XC over CAN-XL. So all these options are available, and you have to adapt them. Optionally, you can also use the AUTOSAR Ethernet synchronization based on the IEEE 802.1 AS. There's a protocol described when we map Ethernet frames into the CAN-XL data frames, then we can use this approach. So the benefit is, as I said, we don't have to reinvent the wheel. Anything is available. You just can select from that what is proven in the different applications in the past, and then you can adapt this also to CAN-XL communication. The third thing what is necessary to discuss in the ecosystem is the fragmentation. We see that sometimes there is, if you have really long frames, then there is also a long network latency time. And if you, for example, would use if you would map an Ethernet frame into a CAN-XL with 1,500 byte, then at a speed of 8 megabit per second, you have approximately 1,7 millisecond of network latency time. This is in some applications too long. Normally, the automotive industry is requesting something like 1 millisecond and not more. To achieve this, we can fragment the frame. So we have sent, instead of one frame, we sent multiple frames. You see it in the example. We have different communication, FD, XL, and then we have a very long frame. And then in the middle of or in the beginning or during the transmission, there's a high power data frame requested to be transmitted. And you have to wait. In worst case, 1,7 milliseconds. And this delay is unacceptable for your application. So you fragment the frame and you send it in 4 pieces. And then you can have the transmission of the high power data frame within 1 millisecond, which might be your requirement. So this is something also what we have standardized and in CiA 630-3, and how this can be implemented is described there. And we have already tested this, and Rainer mentioned this. We have done several CiA Plugfest where we have proven not only the hardware, which we have from different manufacturers by means of protocol controllers and transceivers. We also tested the fragmentation from different companies implemented in software. And then we can transmit shorter segments, and we reassemble them on the receiving side. There's more to do, and also we need to test things. And we thought that eye diagrams would be very benefitable, but then we saw that this is not well standardized. And now we have the CiA 612-5 document where we are specifying how to show the eye diagrams by means of oscilloscopes, for example. So we specifying the input parameters, we specifying the superimposition and the eye mask shape. And we have to consider that we have 2 different shapes, one for the arbitration phase and one for the data phase. And of course, we need to configure by some means the synchronous jump width. And all this is in the document described, and then can be implemented by means of oscilloscope manufacturers, so that you can then diagnostic and see the quality of your different bits on the physical layer. As Rainer has mentioned, we have a lot of freedom regarding the topology which we can select and the number of nodes, and therefore we need those tools to prove that if you are the system designer. This is different to other technologies which are very restrictive regarding the topology and the number of nodes. So we are more open. You can adjust this, but then you need such tools, and they are also then part of the KNXL ecosystem. Let's have a look at the applications which are intended and which are under development. We already have said that most of the applications coming from road vehicles in the beginning, but this is not limited to that, but this is the first application where we see that KNXL will be adapted. Just to make it clear, once again, we have different protocol types, CAN Classic, CAN FD, and CAN XL, and we can mix all of them on the same network segment. And we have different transceiver types or physical media attachment sublayers. Then we have the normal CAN FD with improved symmetry features. We have CAN SIG, and we have CAN SIG XL, which support the fast mode. And Rainer mentioned this. In this fast mode, we switch off the error indication. And this is then the highest speed which we can support, and this goes up to 20 megabit per second if you choose an appropriate topology for this network. So we can mix all of these things, and this is important to understand. This is why we can't say you can use KNXL only for a specific application. It can be used to extend things, existing things, as well as completely new ones. So we have the possibility to have a mixed CAN XL FD communication. So if you have an FD network and then you want to extend this because you have more need for bandwidth requirements, then you can add things. You can add Ethernet communication to your network. You can have also a normal CAN XL data frames to be transmitted. And you can still use your FD frames and use your application as it was designed a couple of years ago. The other option is you say, I want to have only CAN XL nodes in my network. Then you can have CAN XL communication as well as then the Ethernet communication from the higher layer point of view. So this can go up to 20 megabit per second. And if you switch off the error signaling, then you are limited to 8 megabit per second. This depends on what you want to achieve. And the last one is that you want to have Ethernet-based communication from the higher layer point of view. And then you can use this up to 20 megabit. And you have then also the error signaling on the Ethernet level in the software. What it means this for passenger cars? You can have an increased bandwidth because the bandwidth which you currently have for CAN FD, for example, is not sufficient anymore because you want to have more radar systems on or radar devices on your network. That's one of the things. The other thing is you want to increase the payload because the 64-byte of CAN FD is not sufficient for your application. Here you can add more information into one data frame, and this is in particular necessary for corner radars. Because today you have about 30 objects which you can detect, and might be in the future there will be more. This is another application, and we can have also the intention that we want to diversify our zonal redundancy. So when we have a zonal architecture based on Ethernet, we want to have, for some other reasons, might be reliability reasons or robustness reason, a second different network technology used. And this could be done by CAN XL because we also can transmit very large data. We can transmit from the software point of view Ethernet applications. And if you have latency critical applications, also this is an idea to improve this by means of CAN XL communication. We expect that first Chinese automakers will use CAN XL on the road in 2028. So you see there is already some developments are ongoing, and with a normal 1-year delay or something like that, it could be also the year 29, to be honest. This shows you what is the first application in China. So we think that car makers will connect radar devices more than today, with the capability to detect more items as in the past. There's another interest in to use CAN XL as an integration network, in particular for commercial vehicles. You see here an example that we have off-highway or road vehicle with in-vehicle networks, and then we have additional equipment to be attached. That can be a temporary or fixed front-end machine tool on both sides, on the front and the rear. And you might have also fixed mounted machine tools and telematic and fleet management system interfaces. All this requires a lot of information to be exchanged, and CAN XL provides with its capability to send CAN FD frames, CAN Classic frames, as well as CAN XL frames. This would be a very good idea to have then the CAN XL as a base technology for integrating things. Just to give you an example, this is a firefighting truck. Here we have different virtual devices to be connected. This is the in-vehicle gateway, the fleet management unit, the telematic gateway unit, a secondary displays, a power take-off manager unit, and you have then the dedicated additional subsystems for fire can host controller, for turntable ladder units, for outrigger control units, or water and foam container units. All this can be integrated by means of this CAN XL body application network. Why we can do so? This is because we have now in CAN XL, and Rainer mentioned this already, we have additional fields which we don't have had in the past. One of them is the service data unit type. Here we can indicate which higher layer protocol we are using. So we are not more limited to one higher layer protocol. We can use different ones, so we can share this same cable with different applications and support this. Also, the virtual CAN network ID is an important feature so that we can indicate that this frame is not intended for a specific node. You can now forward this to other network segments. And last but not least, we have the data field, which is quite long. And we can also introduce that what is called multi-PDU concept, showing you in the next slide. We have also a specification for that, CiA 611-2. This specifies the multi-PDU. So we use the large frame to send in one shot, so to say, different smaller packages or PDUs. They come from sub-layered networks and might be from KNFD networks or classic CAN networks, and we can map them into one large CAN-XL frame. And then we can provide data consistency by means of this mechanism. So what is about the standards and the specification status? Standardization has been taken place in the last 2 years, and we have already published the ISO 11898-1 document in 2024. So this was the third edition, including the CAN-XL data link layer specification. We also have the ISO 11898-2, which specifies the SiC XL transceiver chips. Unfortunately, there were some errors in the current document because some of the comments were not accepted by the ISO Central Secretariat. So we have updated this, and the fourth edition is already in publication. Yesterday we have had a final meeting, and so now we can go and publish this with the work to be done in the ISO Central Secretariat. The related conformance test plans are still under revision and under development. This is for the data link layer as well as for the physical layer. We also have started to do some work on the transport layer. So part 2 is under revision already, and CARIAD and Volkswagen and other experts have submitted ideas how to make a transport protocol for CAN-XL. So if you have larger data than 2048 to be downloaded. And there's also a need then to adapt the part 5, the specification for an in-vehicle network connected to the diagnostic link connector. This also needs to be revised, but this will be done when the part 2 is finalized. CiA is still working on the entire ecosystem, and that's not all of these things will be submitted to ISO. First of all, we have the CiA 611 series. This is a CAN-XL higher layer services. Part 1 specifies the SDU types. You may remember that there is a field in the CAN-XL data frame, and how to use it, this is specified there. We are updating this in the moment because we need an additional SDU types for the ISO transport protocol and for the MACsec key agreement. And part 2 is the multi-PDU concept. This is released, and at the moment there's no need to touch it. We have also the CiA 612 series. This includes guidelines and application notes. All of them are more or less not published yet, but some of them are already in the CiA finalized, and just with the quality, what we have to do and to improve the quality of the documents by means of editing things and layout things. This will be done very shortly. CiA 613, this includes the, in particular, the CAN-SEC specification in part 2. And this is already also in publication because the technical work is done. Part 3, the frame fragmentation is still under development. There are some minor technical issues, but then this will also be released. EMC evaluation is also under development. This will be submitted to IEC for international standardization when this is once technically mature. CiA 910 series, and this is very important. These are the simulation model because we need to simulate our network designs. And we have released part 1 and part 2, and part 3 is already in publication. So you see, we are not at the end of the story, but we are quite far, and there will be new documents available beginning of next year. The CAN-XL product situation is quite good. So we have a lot of protocol IP cores for CAN-XL available from different companies. You can select, if you're a chip maker, you can select from different sources the protocol IP cores. Microcontrollers, we have a similar situation. There are engineering samples available worldwide, operating companies as well as from local heroes in China. We see an increasing interest in China to produce microcontrollers with CAN-XL. For example, Giga Device, for example, SemiDrive, for example, Star Power. These are Chinese, and TMC, these are Chinese brands. And then we have the well-known Infineon, Renesas, STM companies which provide microcontrollers with CAN-XL, mainly in engineering samples. What is really available is the Bosch radar sensor system on chip. And I think this shows that this is the first application where we use CAN-XL to interconnect radar sensors. Transceiver chips are available from 3 companies, from Bosch, NXP, and Texas Instruments. We have all 3 we have proved in the CiA Plugfests. There are also board-level products available from different parties, including those from China and from Tosun and ZLG, but also from European ones and American ones. There are also some CAN-XL related tools available. There's a validation tool available from CNS Group. Tosun has a data logger. Vector has a development and test tool, as well as a protocol analyzer. For those which are really looking into the physical layer, all the major oscilloscope manufacturers provide trigger and decoder for their products from Keysight to ZLG in alphabetical order. And last but not least, we have CAN-XL related software available. Bosch provides a driver for its evaluation board. Volkswagen supports the GitHub, the Linux proof of concept for the frame fragmentation, which I have introduced before. And we also have a Linux kernel version 6.1 and higher, also supported by Volkswagen. And we have the AUTOSAR protocol stack, a prototype from Vector. So you see, you can start playing with CAN-XL. You can start your development, and some OEMs have done this already, and they are in progress with their developments. And as said, we expect in about 3 to 4 years the first cars with CAN-XL on the roads. So that was my presentation.
Okay, maybe I can remind you on following us on our social media channels. We provide a lot of current content on LinkedIn. We provide the recordings also from this session on our YouTube channel, and also for our Chinese community, we try to provide some valuable information. We have several publications. So first to mention in this regard now the 3 weekly CAN community news, so that you do not miss any information, any event. And there I like to highlight also the CiA member days taking place in March and beginning of next year. So yeah, the CiA website, check it out. It's a treasure trove for information. All the relevant information, current information is provided there. And here you see also the link to the CAN-XL sub website that we are providing. Yeah, if there's no more requests, then thank you very much for joining this webinar.